Hello, my name is Sekwang Kang, who will deliver to you on the subject of the prospect of the future marine industry. As you may already feel, the technologies of the fourth industrial revolution have already penetrated deep all around us, so that we cannot spend a day without experiencing various new technologies that are the output of the fourth industrial revolution. In the midst of such rapid change, the shipping industry is at an important time to dramatically reduce the atmospheric emission of greenhouse gas due to the characteristic of the industry that is responsible for 90% of the world's goods transport. Therefore, in this lecture, I would like to share the future of the shipping industry in the midst of these changes. Before entering to the lecture, briefly I would like to introduce myself. After graduating from Korean Maritime and Ocean University in 1982, I received my master and doctorate degrees from same university. I have been working in the shipping industry for 41 years now. During my 41 years of working for shipping companies, I performed the consolidated ship management of all new building project for about more 90 vessels like as LNGC, LPGC, VLCC, and bulk carriers, and sale and purchase project of about 30 ships. Now I am working at the shipping company to transport the heavy cargoes such as offshore structures and mega ship blocks, and I am participating in the KOICA project, which establishes a master plan for the development of Ocean University of Sri Lanka and builds capacity as an expert in the field of marine business. I am teaching in the Graduate School of Marine Finance of Korean Maritime and Ocean University and very interested in the new and changing future, so I am very curious about how our industry and life will be changed in the future. Before starting this lecture with the subject of the prospect of the future marine industry, I reviewed the related data to see what the future prospects for the shipping industry are. I analyzed the major trends of the shipping industry in 2022, which came out at the end of 2021. As a result, major trends in the shipping industry could be divided into technological changes related to the fourth industrial revolution and responses to climate change. Contents in blue are related to the fourth industrial revolution, and contents in green are trends in response to climate environment. As another reference, on October 22, 2021, a webinar with the subject of green shipping and new technologies, innovation and sustainability for the European maritime industry was implemented. The topic of a webinar conducted with real-time streaming were green and new technology. And if you look at the following video clip, you can see that about the 80 leading shipping companies took interest in these topics and participated. Perhaps our future is expected to respond to climate change in the midst of changes in the technologies of the fourth industrial revolution. DMV, a Norwegian classification society, has set 4 strategic goals while presenting a roadmap for digital transformation in the period from 2020 to 2050. The strategic goals are 20% OPEX reduction, 5% VOEX reduction, IMO compliant decarbonization, and zero incident to safety, and various technologies to achieve them are listed on this map. All of the technologies marked on this roadmap can be found in innovative future ship management technologies and responses to climate change. Therefore, this lecture will help you understand the contents of the fourth industrial revolution, covering all areas of the shipping industry, learn the graphing situation of related technologies, and then learn the contents related to the climate environment. The table of contents for this lecture is as follows. As you well know, one of the characteristics of the technologies of the fourth industrial revolution is digital. Therefore, I have prepared several video clips related to the contents of some pages to be presented so that you can better understand the disruptive digital world. The term of fourth industrial revolution was firstly used in the World Economic Forum in 2016. Through this video clip, we can understand the definition of the fourth industrial revolution and what changes will occur in our lives in the future. As you have seen in this video clip, the reality is that we cannot live a day without using the technology of the fourth industrial revolution. Then let's go in earnest from now on. What is the fourth industrial revolution? If the first industrial revolution was mechanization through the steam engine, the second industrial revolution could be said to be the establishment of a mass production system due to Edison's invention of electricity. And the third industrial revolution was an automation revolution caused by computer and the internet. And the fourth industrial revolution can be said to be a destructive revolution, such as the cyber-physical system, using the Internet of Things, cloud, robots, and so on. Through the lasted each period from the first to the fourth industrial revolution, you can find that the cycle between each industrial revolution is getting short, and the width of the impact to our lives by each industrial revolution is getting wider. The representative technology of the fourth industrial revolution is the cyber-physical system that made Smart Factory 4.0 in German possible. Cyber-physical system, CPS, is the integrations of the computation, networking, and physical processes. Let's see the following video clip to see how German Siemens actually manufactured products using CPS.
A self-organizing factory that entirely configures and organizes itself and responds to changing requirements, and where humans and machines seamlessly collaborate. This vision is becoming a reality in the Siemens Living Lab for cyber-physical production systems.
Alexa, trigger product logo echo.
Checking if we can produce it.
The manufacturing of a product starts in virtual reality with the help of simulation technologies. The cyber-physical production system first checks whether the production is feasible. The machines in the factory provide detailed information about their production skills and constraints. Based on this information, the system generates a digital twin of the product and compares the required production steps with the production skills of all machines and humans in the factory. The machine gets the knowledge of how the product shall be made directly from the digital twin. Based on the information about how the parts are to be assembled, the system dynamically calculates all necessary steps and carries out the production autonomously. This means that the product steers its own production. This is an important feature of Industry 4.0 solutions. Siemens enhances the skills of the machines through machine learning, intelligent sensors, and speech recognition. This optimizes the production process and increases the quality of the product. Safety requirements are also developed to ensure that people and machines can work together safely. In the future, cyber-physical production systems will better meet customer needs and manufacture products in a faster, more individualized, and more efficient manner.
Siemens. Ingenuity for life.
It is said that the CPS is used for smart grid and autonomous automation system. Let's take a look at the Ocado, a British fresh food delivery company that actually utilizes this system. Ocado is the world's largest online grocery specialty supermarket with annual sales of over £1 billion. Ocado's warehouse of the size of 3 football fields has thousands of robots zooming around the grid system to pack groceries. They communicate on a 4G network to avoid bumping into each other. 1,100 robots in Ocado's warehouse move 50 to 60 kilometers per day to handle 65,000 orders per week. The combined distance traveled by them is equivalent to 4.5 times the circumference of the Earth every day. Let's see how Ocado utilizes CPS and the machine-to-machine communication through the following video clip. Let's take a close look at what the fourth industrial revolution is. The main characteristic of the fourth industrial revolution are hyper-connected and hyper-intelligent, and the main technologies driving these characteristics are physics, digital, and biology. In reality, the disruptive innovation of the fourth industrial revolution can be experienced when these technologies converge at the same time rather than when they move individually. To understand the hyper-connected, one of the two major features, as of April 2021, 5.27 billion people, over 67.1% of the global population, over 7.85 billion, are using mobile phones, and 4.72 billion, over 60.1%, are using the internet. The number of connected devices was 1 per person in 2008, but increased to 6.58 in 2020. As you know, we are living in a hyper-connected world. Let's just take a look at another video clip that shows hyper-connected among the technologies of the fourth industrial revolution. This video clip is an example of a future car insurance business using IoT and ICT.
No. It's just construction. That's all. No. I'm not driving.
Are you okay?
Yeah, you?
I'm good.
Oh, no, not you. Listen, I'm gonna have to call my agent. I'm gonna get right back to you.
Mr. Burton, this is Insure Corp. We've received sensor data that indicates you were in an accident. Are you injured in any way?
I'm not injured, no.
Is anyone else injured?
I don't believe so.
Okay, where's my agent's number?
We have pinpointed your location, and we are showing your car is not drivable. So we are dispatching an Uber car to take you to your destination.
That would be great.
I'm pressing 1. English. E-N-G-L-I, English.
May we give your coordinates to our appraiser drone to perform the appraisal?
Absolutely.
We have received the photos, assessed the damage, authorized the repair, selected a qualified repair facility, and have dispatched a tow truck to take your vehicle to that facility.
Perfect.
Yes, hi, this is... Yes, I'll hold.
We have looked up the other vehicle's insurance, transmitted the appropriate data to create the claim, and filed the California SR1 accident report. Can you confirm the information is correct on your phone, then hit the accept button?
I'll check it right now. Okay, all done.
Thank you. Your Uber car is arriving now.
I see it coming.
Accident, not payment. Accident.
Your tow truck should be there now. Don't forget to leave your keys in the vehicle. Thank you for using Insure Corp, powered by Pivotal Labs.
If you look at the global internet usage by region on this page, you can see that the internet usage rate is gradually increasing in the developing countries, especially Africa and Asia region, rather than developed countries. There are many ways to make the internet available in areas where do not have internet access. Global leading companies have made various attempts to provide the internet service to places that internet service cannot reach as follows. Facebook envisioned the Aquila project using drones, and Google envisioned the Loon project using balloon. These vehicles stay in the stratosphere for about 3 months and share the Wi-Fi signal received from the ground to other vehicles to provide the communication services to areas that need the internet. As you can see, there are several companies like Facebook and Google that are spreading the idea. Among them, SpaceX's Starlink project is promoting satellite internet access as a more aggressive strategy. Through this video clip, you can understand how Starlink is promoting their business. The second characteristic of the fourth industrial revolution is hyper-intelligence. In particular, due to the hyper-intelligence of AI, it is difficult for anyone to predict what kind of world will unfold in the future. For example, in 1997, IBM Deep Blue won the World Chess Game champion, Mr. Garry Kasparov. In 2011, IBM Watson beat the consecutive quiz show winner at the Jeopardy quiz show in the United States. In 2016, Korean Go genius Sedo Lee and Google's AlphaGo played a game of Go, but Sedo Lee lost to AlphaGo. After that, AlphaGo thought that there was no human rival in the game of Go anymore. So AlphaGo left the world of human Go after giving 50 notations that the AlphaGos played against each other, and then conducting the research at the British National Institute of Health to cure incurable diseases of mankind. From now on, we will see the evolution of AI through 3 video clips. The first video clip is actually on IBM Watson playing a quiz game with the American quiz king, Ken Jennings, at the Jeopardy quiz show.
Welcome to the deciding game in the IBM Challenge here on Jeopardy.
And here it is.
인간 퀴즈왕 켄 제닝스와 브래드 러터가 컴퓨터 왓슨과 대결을 벌입니다.
If you're ready, make your first choice.
Let's take alternate meanings for 200, Alex.
Four-letter word for a vantage point or a belief. Brad.
What is a view?
Watson.
Who is Franz Liszt?
You are right.
What is violin?
Good.
Who is the church lady?
Yes. Watson.
What is narcolepsy?
You are right, and with that.
왓슨은 사람의 말을 이해하고 사람이 쓰는 언어로 대답했습니다.
Same category, 1600.
Answer. Very double.
인간만의 고유한 능력이었던 지적 판단의 영역마저 컴퓨터에게 자리를 내주는 순간이었습니다.
And I remember thinking, this is it. I felt obsolete. I felt like a Detroit factory worker of the 80s seeing a robot that could now do his job on the assembly line. I felt like quiz show contestant was now the first job that had become obsolete under this new regime of thinking computers. And it hasn't been the last.
This video clip indirectly shows how AlphaGo was able to defeat the world-famous Go genius Sedo Lee through Demis Hassabis, who designed AlphaGo itself. This video clip shows us how AI learns and evolves on its own. And it is very impressive that the Demis Hassabis is wondering how AlphaGo came to do deep learning with that strategy.
There's a second video. It's my favorite video, actually. So this is a game of Breakout, and there's more gradations here of the agent getting better, the system getting better. So this is after 100 games. So just 100 games, and you can see, again here, the system is pretty terrible, but you can probably convince yourself that maybe it's starting to get the hang of the fact that it should move the bat towards the ball. Now this is after 300 games, so it's now hitting the ball back pretty consistently, and it's almost never missing, so it's about as good as the best humans can be at this game. And then we thought, that's pretty cool, but what would happen if we just left the machine playing the game for a couple more 100 games? And this amazing thing happened. What happened was it discovered the optimal strategy was to dig a tunnel around the left-hand side here and then send the ball, with this unbelievable accuracy round the back. So that's really cool because actually the brilliant programmers and researchers who are on this program, they're brilliant at programming and coming up with algorithms, but they're not so good at playing Atari. So they didn't actually know that strategy for themselves. So this is something that their own creation taught them.
When IBM Watson and Google's AlphaGo battled the humans, they were connected to a huge centralized control room. But as just one simple computer, the newly evolved AlphaGo Zero show how AI learns on its own through the following video clip. Let's see.
AlphaGo Zero is the strongest Go program in the world. It outperformed all previous versions of AlphaGo. Specifically, it defeated the version of AlphaGo that won against the world champion Lee Sedol, and it beat that version of AlphaGo by 100 games to 0. The most important idea in AlphaGo Zero is that it learns completely tabula rasa. That means it starts completely from a blank slate and figures out for itself only from self-play and without any human knowledge, without any human data, without any human examples or features or intervention from humans. It discovers how to play the game of Go completely from first principles. So what we started to see was that AlphaGo Zero not only rediscovered the common patterns and openings that humans tend to play, these Joseki patterns that humans play in the corners, it also learned them, discovered them, and ultimately discarded them in preference for its own variants, which humans don't even know about or play at the moment. People tend to assume that machine learning is all about big data and massive amounts of computation, but actually what we saw in AlphaGo Zero is that algorithms matter much more than either compute or data availability. In fact, in AlphaGo Zero, we use more than an order of magnitude less computation than we used in previous versions of AlphaGo, and yet it was able to perform at a much higher level due to using much more principled algorithms than we had before. So tabula rasa learning is extremely important to our goals and ambitions at DeepMind, and the reason is that if you can achieve tabula rasa learning, you really have an agent that can be transplanted from the game of Go to any other domain. You untie yourself from the specifics of the domain you're in and you come up with an algorithm which is so general that it can be applied anywhere.
From now on, let's talk about the major technologies of the fourth industrial revolution. As already mentioned, the major technology trends are physics, digital, and biology. First, it is physics, such as the source of technologies such as unmanned vehicle, 3D printing, robotics, and etc. In addition, these will include the dream materials such as graphene that are used in foldable mobile phones that Samsung Electronics made firstly. Now let's look at practical application examples of this technology trend. This slide shows example of each application area of the aforementioned physics technology. The upper left is an unmanned ship that catches submarines and can perform its own work for 3 months under the autonomous operation. And the lower left robot is the KUKA robot that enabled the German Industry 4.0, and the upper right is the 3D print that makes artificial human organs. The functions of robots are becoming more diverse. Since 2012, the University of California Hospital in San Francisco, USA is using robots to dispense medicines and deliver to patients. In the past, there were 7,000 casualties and loss of $3.5 billion per year due to incorrect medicine treatment. But by introducing this robot processing system, there were no more mistakes in any one case despite the 6 million medications. This video clip is about the robotic pharmacist at the University of California, which we talked just before. This is the last slide of the first session.
We've been focused on reducing cost and improving quality to patients for years, and technology really gives us an opportunity to take big strides in that area. Our new pharmacy had a rather ignominious start in that we had a medical error here in 2008 where a nurse made an error and we overdosed a patient. And at that point we made a commitment that we didn't want that to ever happen again. And so we looked into automation of our pharmacy, and in fact what we now have is a pill picker that fills all of the pharmaceutical orders for our patients. We also do it for infusions as well. Starting that pharmacy was very costly for us, but has it saved us money? Has it been worth it? Absolutely, because we've reduced medical errors, medication errors enormously. In terms of accuracy, the machine counts pills much better than humans do. When we added the robotic pharmacy, we redeployed the pharmacists that had been counting pills and putting them in bottles to have them work with the physician teams and round with patients to help them understand medications better. So we feel like it was a win-win. The pharmacists got out of doing work that was menial for them, and it allowed the machines to do what they do best, which is accurately count pills. When we opened our new Mission Bay Hospital in 2015, it's a long horizontal hospital of a few football fields long. And one of the big challenges that we knew we had in that hospital is how we moved linen, how we got food, how we got medication delivered to all the units. And we looked at using robotic tugs to do this. The choice for us was, do we use tugs or do we go spend a fortune trying to recruit lower skilled employees in to do that kind of work? And it just makes a lot of sense, particularly in a high cost place like the Bay Area, to go with automation when you can. I think when you introduce any new technology that has the potential to replace humans, there is fear and people are worried about losing their jobs. But in healthcare, what we're trying to do is to move people away from doing things that are menial, that can be done by machines, and training them to do higher level services. So could I tell you that no one's worried about it on the labor front? No. The people are concerned about loss of jobs. But the bigger issue, I think, is we can deploy people to doing things that they're better suited to doing than machines, and have the machines do the menial work. That's how we want to grow.
Hey there, thanks for checking out CNBC on YouTube. Be sure to subscribe to stay up to date on all of the day's biggest stories. You can also click on any of the videos around me to watch the latest from CNBC. Thanks for watching.